is also a easy problem. Okay, so we'll write the name of the problem as removing half. Okay, removing halves. So in this problem statement, what I can see is that we will be given, it's a problem of binary search tree. Okay, from binary tree we will be given a binary tree. Okay, so we will be given a binary tree and we need to remove all the half nodes which have only one child, return the node of the modified tree after removing all the half nodes. The output will be judged by in order traversal. Okay, so we have to follow an in order traversal of the resultant tree inside the driver code. Okay, so what you can see in the question, we have a tree. 5 tree is subdivided into 7 and 8, and 7 is divided into 2. So the output is 2, 5 and 8. Okay. So in the above tree, the node 7 has only one single child, only single child. After removing the node, the tree becomes 2, 5 and 8. Okay. After removing the node, so we have to remove this node, the tree becomes 2, 5, 8. Hence the answer is 2, 5, 8 and it's 2, 5, 8. Okay. So if you don't know in order traversal, it follows this criteria: left, root, right. Okay, what I have done is the in order traversal follows this technique: the left, root and the right. That's the reason the answer is first. That's the reason in the answer we are giving 2 first, 2 first followed by 5 then 8. Okay, explanation in the above trend. Okay, now let's take another example over here. Now let us take another example. So if I see another example, we have a tree 2. Okay, we have a tree 2 which is subdivided into 7 and 5. Here there are no nodes which has only one child, so the tree remains same. Yeah, if you see, and also they've written the answer in 7, 2 and 5. Okay, so this was about the problem statement. We have to remove the tree which does not have a child, and like that. Okay, so if you see in the tree, the 7 has only one single child. After removing the node, the tree becomes. So if you see, we have to remove all the half nodes which have only one child. So first what we are doing is we are taking data. Okay, we are taking the left and right pointers, the left and right sides of the binary tree, and then we are initialing the data as d, which the user will give. First we have null. First we are assuming that there is no values. Okay, first we are checking the base condition. If the root is equals to null, then we are going to return null. Now we have to traverse, right? So we have to traverse by using recursion. So in recursion we are taking the root dot left value as remove half nodes, the function, and then we are calling root dot left. Similarly for the right node we are doing root dot left. Now we are checking if the left is null and the root then root dot right. Okay, so basically it is saying, suppose you have this thing. Okay, you have a left and you have a right. Okay, suppose there is no left child. What we are going to do is our root is going to move in this direction. So root is equals to root dot right, and this gets satisfied. Only if the right is not null, means the right has some values. Okay, now let's come to this condition. If the right has no values. Okay, so if the right has no values, then only one direction is that one we can go, right? So if I want to go to this direction, then I have to do is root is equals to root dot left. That is the thing they have done. And finally we are going to return the root. This is a very simple problem. Okay, then we are going to return the root. This is a very simple problem, and we are going to return the Luften in order traversal. So in order traversal, just remember, first is left, then root, then node value, and then the right value. Okay, so this was the problem statement, and I hope you could understand and visualize this problem statement, and it will help you solve more problem statements easily. Thank you so much, and keep watching, and like, share and subscribe to this channel.